So we are going to hop into section 4.7, which is factoring binomials, but I want to spend literally 5 minutes just reviewing perfect square trinomials. We covered this in the last section, but it is so important that I really want to make sure you have a clear understanding of these perfect square trinomials. So I'm first going to start off here with a plus b squared. So that is a factored form of a perfect square trinomial. It's a binomial that's in parentheses raised to the second power. All right, and so I could go ahead and, using the definition of an exponent, write this as a plus b times a plus b. And then I would just multiply this out using FOIL or the distributive property, okay? So I take that first term, multiply it times each of the terms in that second binomial, and I would just get a squared plus ab. Then I take, and I'm going to take that second term of b and multiply it times the two terms in that second binomial. And so I get BA, which is the same thing as AB. I can just switch the order because it's multiplication. And then plus B squared. Then I combine like terms, and so I'm left with A squared plus 2AB plus B squared. And so what we have here is a perfect square trinomial. Okay, and you will always get that when you have a binomial raised to the second power. It's always going to result in that perfect square trinomial. The a plus b squared is the factored form of that trinomial. All right, so let's look at the next one. A minus b squared looks very similar. It's a binomial raised to the second power. And so again, this is going to result in a perfect square trinomial. So I'm going to take a minus b. That's the definition of an exponent. So then I get a squared minus ab. Now I'm going to take the b and multiply it out. So minus ab again plus b squared. So when I combine my like terms, I'm left with a squared minus 2ab plus b squared. That is my perfect square trinomial. The only difference between the green one and the blue one is because the original binomial is subtraction, you will see subtraction between the first and the middle term. Okay, so now what we're going to do is we're going to look at these two examples in B. And instead of expanding out and multiplying using FOIL, we're going to use the formulas. Okay, so I noticed two things. One, I have a binomial raised to the second power. Second thing that I notice is I have a subtraction sign in my binomial. Okay, so that means I'm going to use the blue formula. Okay, and so this gives me, I'm just going to go ahead and the 3x is my A, and the 2 is my B. I don't say a negative 2, okay? It's the A is 3x, B is a positive 2. Okay, so now when I put that into that formula, it's going to be 3x squared minus 2, which is part of my formula, times that A of 3x times my B, which is 2. Then plus my B squared. Now I just go through and I simplify. 3x squared is going to be 9x squared. Be careful. You have to make sure to apply that exponent to that 3. And then minus, and I multiply my integers. 2 times 3 is 6, times 2 is 12, so I get 12x plus 2 squared is 4. There I go. This is my perfect square trinomial. Okay, now let's do number 2. Number 2 is a fraction. Most people look at that and they're like, no, thank you. And yet it's not hard, okay? So our A is going to be 1/2 x. Our B is 4. We're going to use our green formula to take the factored form, which is our binomial squared, and turn it into a perfect square trinomial. Okay, so this is going to be 1/2 x squared plus 2 times 1/2 x times 4 plus 4 squared. Okay, so now I'm going to go back and I'm going to simplify. 1/2 squared. Remember I showed you this trick before? You just take and square the numerator and square the denominator. So 1 squared is 1, 2 squared is 4. So 1/2 squared is 1/4. So 1/4 x squared plus, okay, well, 2 times 1/2 is 1. 1 times 4 is 4. So I get 4x plus 4 squared is 16. There we go. That's our perfect square trinomial. Okay, now, this always happens with math. We finally get to the point where we're like, yeah, I got it. Yes. And then there's a twist. Okay, so let me tell you the twist. Not all perfect things that look like they're a perfect square trinomial are truly a perfect square trinomial. Sometimes we have imposters. So how do we know whether we have an imposter? Okay, so if you take your perfect square trinomial, let's go back to the one we just did, okay? And so this one in green. And so I would create my parentheses raised to the second power. I take the square root of 1/4 x squared, that's 1/2 x. I take the square root of 16, which is 4, and I put a plus. Okay, that gets us right back where we started. But let's say we didn't know that. All right, so the way to check is you just check to make sure that you're going to get that middle term. How do we do that? Well, we take 2 times A times B. So 2 times each of those terms inside the binomial multiplied. So that's going to be 2 times 1/2 x times 4, which equals 4x. There we go. So that is not an imposter. It truly is a perfect square trinomial. All right. So as we look at this row, they both look like perfect square trinomials. Okay. I've got my first term, which is a perfect square. I've got my last term, which is a perfect square, which is exactly what I have on the other side with the other trinomial. Only one of them is a perfect square trinomial. The other one is an imposter. How do we know? Okay, well, let's go ahead and create our binomial squared. Take the square root of that x squared. It's x. The square root of 9, 3. And then because there's a plus sign between the first and the middle term, it's a plus in our binomial. Now, to check this, okay, I'm going to use 2AB. So that'd be 2 times x times 3. Ah, that's 6x. So there's my 6x. That one is my perfect square trinomial. This one on the left is the imposter. It's still a good trinomial. I don't want to make it feel bad. It's just not a perfect square trinomial. All right, let's look at this next one. All right, so for this next one, when we look across, I'm a little bit confused. My first term is the same. Then I've got a y squared. I've got a 25x squared. I've got a y squared. My middle terms are the same. Which is the imposter? Ah, look at what's different. Between the middle and the third term, the one on the left has a plus, the one on the right has a subtraction. Let's go back up. When you are dealing with perfect square trinomials, the sign between the middle and the third term is always an addition sign. It's always a plus. So knowing that, the second one, or the one on the right, is our imposter. That is not a perfect square trinomial. All right, let's try the third one here. Okay, so, oh, I didn't mean to do that. Figure out which one is the imposter. The one on the left or the one on the right. Okay, so what we want to do is we want to create our binomial squared. Take the square root of 36x squared, which is 6x. The square root of 25, which is 5. Because there's a subtraction sign between the first and the middle, there's a subtraction sign in our binomial. So to check this, it's going to be 2 times our two terms. So 2 times 6x times 5, which is going to be 60x. There's our 60x. That is the perfect square trinomial. This other one is our imposter. Okay. So now you have a deeper understanding of perfect square trinomials, which is going to help you in the future. Now let's go to our other types, to our binomials, okay? And we're going to start first with what is called the difference of two squares. And this one often gets confused with a binomial squared. So remember, we just finished a plus b raised to the second power, and that gave us a perfect square trinomial. Okay, this is very different than the difference of two squares. So for the difference of two squares, each term is squared, and there is always a subtraction sign. When you have the difference of two squares, that results in conjugates, okay? So conjugates have the same terms, but they have opposite signs. One is plus, one is minus. Okay, so a couple things to note here. Any even power is a square. That's good to know. The second thing, the sum of two squares is not factorable. What? What in the heck does that mean? Okay, so if you have a squared plus b squared, that is what we call prime. It is not factorable. You can sit here all day and try and figure out how to factor that. Won't ever happen. Okay, so let's take the difference of two squares and let's see how to do this. Now, okay, this example, I think again, is a little confusing. Let's just start here with 25x squared minus 9y squared. First thing that we notice right away that 25 is a perfect square. And because we have an even exponent, that is a perfect square. 9 is a perfect square. Because we have an even exponent, that is a perfect square too. So the last thing I want to check is that I have a subtraction sign. And I do. So that means right away, I can go ahead, create my two binomials and put this in factored form. So this is going to be, my first term is going to be the square root of 25x squared. So the square root of 25 is 5, square root of x squared, x. And I put that as the first term in both of my binomials. Then I go to the 9y squared. The square root of 9 is 3, and then the square root of y squared is y. So I put that in both of these. One of them is addition, one of them is subtraction. I'm done. Okay, that is our factored form. All right, so this is easy to do. 36x squared minus 1. I see that I have a perfect square. And don't forget, people forget, 1 is a perfect square. 1 times 1 equals 1. So, because I have subtraction, this is an example of the difference of two squares. Okay? And so, I'm going to be able to go directly to my two binomials. I take the square root of 36x squared. That's 6x. I put it on the front end of each of those binomials. I take the square root of 1, which is just 1. One of these is plus, the second one is minus. Done. Okay, let's go ahead and look at this next one. So, when you have fractions, all you need to do is if all of your numerators and denominators are perfect squares, then the fraction itself is a perfect square. And that's the case here. Okay, so that means I can go directly to my two binomials. The square root of 1/4 is 1/2. Okay, the square root of 1 is 1, square root of 4 is 2. And then I've got y. So I put 1/2 y. Now I take 9/25. The square root of 9 is 3, square root of 25 is 5. So 3/5 is the square root of 9/25. One of these is plus, one is minus. Done. See, it looks so ugly, and it wasn't. All right. Oh my gosh, look at number 3. That's a little different. Look at this. That exponent is an 8. Well, that doesn't seem fair. We haven't done one like that. However, any even exponent, okay, so let's just remember that even exponent is going to be a perfect square. So how do I work with that? Oh, it's not hard at all. All you need to do, because we're taking squares, which are an exponent of 2 raised to the second power, okay? We divide that exponent by 2, and that will give us the root. Well, that's not so bad, okay? So this is going to be, we're going to go ahead and set up our binomials. So square root of 49 is 7. That's because 7 squared equals 49. So now for that z, the root is z to the 4th. Okay. So now let's go ahead. So we've got 7z to the 4th. Okay. So now let's take 225x squared. You might not know off the top of your head to the square root of 225. And you can use your calculator under the math function to find it. It is going to be 15. So that's going to be 15x, 15x. One is plus, one is minus. Now this is a good one for us to check. All right. So let's go ahead and do that. What I'm going to do is take my first term and multiply it times each of the terms in that second binomial. So that's going to give us 7z to the 4th squared. 7z to the 4th times 7z to the 4th. Okay? And then minus, and then I've got this 7z to the 4th times 15x. Okay? Now I'm going to take the 15x in my first binomial and multiply it times each of the terms in that second binomial. So I get plus, and I'm going to write 7z to the 4th times 15x, and then minus 15x squared. Okay, well, our middle terms are exactly the same, except that one is minus and one is plus. And so they cancel each other out. And so we just end up with 7z to the 4th squared minus 15x squared. And when I multiply that out, I get 49z to the 8th minus 225x squared, which is exactly where I started. Okay, so that check just shows that those conjugates truly are the factored form of that original binomial. Wow, look at problem number 4. Huh. All right. So with this guy, it looks like it's confusing. It's not so bad. Okay. First of all, I see that we have our exponents that are even. So that means I can take a square root of them. And I see that 4 is a perfect square also. So I'm going to go directly to my binomials to create my conjugates. So I'm going to take the square root of m to the 4th. So if I divide that exponent by 2, I would get m squared. And then I do the same thing with the n, and I get n squared, like that. So I've got m squared, n squared. That's crazy. And then I take 4, and the square root of 4 is 2. One of these is plus, one is minus. Shush, done. All right. So you quickly pause and try these 4 problems. I'm going to put the answers here, so then you can press play and check your answers. So for this first one, we get 4n minus 3, 4n plus 3, and it doesn't matter which one you put as plus and which one is minus, whether it's the first or the second, makes no difference. then 3x plus 1, 3x minus 1, then 2m plus 5, 2m minus 5. Oh, I got caught up in my own craziness. That is absolutely wrong. Did you make that same mistake? Ooh, what did we do wrong? This is a plus sign. This is not the difference of two squares. This is the sum of two squares. And the sum of two squares is always prime. Okay. Now, let's do this last one really quick. And so that's going to be x squared minus 10, x squared plus 10. There we go. All right. So now let's go ahead and look at how the difference of squares can be used with grouping. We've got our example there, and I can let you go through that example. I'm just going to kind of dive into problem number 4. You can use that example for reference. So with problem number 4, first thing that I see is that I have here 1, 2, 3, 4 terms. Okay? And so when I see 4 terms, that means I'm going to use grouping. That's my grouping strategy. Okay. So I also notice that my third term is subtraction. So I'm going to change it to addition and put that negative sign with the 25. Now I'm ready to group. So I'm going to group the first 2 terms, the second 2 terms to create my binomials. So out of that first set of terms, I am going to take out a greatest common factor of x squared. And then I'm left with y minus 4. Out of my second binomial, I see that my leading term is negative. So I'm going to take out of here a negative 25. And then I'm left with a positive y minus 4. Well, I have my matching binomials. So I'm going to factor those out. So I've got y minus 4, and then I have x squared minus 25. Here's where you need to be careful. This x squared minus 25, that is the difference of 2 squares. Sometimes I'll call it dots. Difference of 2 squares. And that needs to be factored a little bit more. So I am going to factor that using the conjugates. So that's going to be x minus 5, x plus 5. And then I still bring down this y minus 4. And so this is my factored form. All right, let's do the next one. All right, so I'm going to erase so we've got a little bit more room here. So with this one, same thing as before, my third term has a subtraction, so I'm going to change that to addition, put the negative with the 4, and go ahead and group the first 2 and the second 2. All right, so now I'm going to take out an x squared. That's my greatest common factor of that first binomial. And I'm left with y squared minus 1. Out of that second binomial, I'm going to take out a negative 4. I am left with y squared minus 1. So now I have x squared minus 4, y squared minus 1. Whoa. Both of those binomials are differences of 2 squares, and they can both be factored a little bit more. So for the first one, it'll be x minus 2, x plus 2. For the second one, it's y minus 1, y plus 1. There we go. Now it's fully factored. All right, let's try this next one. So for this one, I'm going to go ahead, use grouping. I'm going to change my third term to addition before I put my parentheses. All right, so out of this first one, I can take out a 4x squared. And then I'm left with x plus 4. Out of the second one, I can take out a negative 9, and I am also left with x plus 4. So I have my matching binomials that I'm going to pull out. X plus 4 times 4x squared minus 9. Well, that second binomial is the difference of two squares. So I'm going to go ahead and factor that. 2x minus 3, 2x plus 3, and then I've still got my x plus 4. Now it's fully factored. Okay, you pause and try this next one. Try that one on your own. All right, so now we're going to go ahead, change that third term to addition and make it a negative 9. Group. Out of that first binomial, we're going to take out an x squared, and we're left with x plus 2. Out of the second binomial, I'm going to take out a negative 9. I'm left with x plus 2. So I've got x plus 2 times x squared minus 9. Oh, and here we have it, a difference of 2 squares. So we're going to factor that second binomial a little bit further. We're going to leave the x plus 2, but then we've got x minus 3, x plus 3. Now it is fully factored. Okay? All right. We've just been dealing with squares. Now we are going to look at both the sum and the difference of cubes. Okay, so we're going to start here with the difference of cubes. So anything that is raised to a multiple, an exponent that's a multiple of 3 is going to be a perfect cube. So that means our variables, or if we can put our coefficients into a format that is raised to the third power, then you can go ahead and that is going to be a perfect cube. All right, so we have in this one, we have a difference of cubes and a sum of cubes. They can both be factored. And so in order to factor them, what we're going to do is we're going to figure out our A, which is really just the cube root of our original. That's going to give us our A. And then we'll figure out our B, which is again the cube root. And then we just plug everything into our formula. To figure out our signs, we're going to remember the acronym SOAP, where our first sign is the same as our original. The second sign is always is opposite of the first one, and then that third sign is always positive. SOAP. All right, well, let's just kind of jump in and try one of these. So they seem like they're really kind of hard, but they're not. The hardest thing is oftentimes people are not super comfortable with cube roots. So one of the things that we can do here is I want to show you on your calculator. Let me just pull up a calculator. So if you go to your calculator, oh, we're done with that. That was from last time. And we go to your math function right here. You can go down to the fourth function, and that is going to tell you whether you have a cube root. So I'm going to hit function 3 on my calculator. Oh, or was it function 4? Let me go back. Let me go back again. Math. Oh, it was function 4. Sorry. We're going to hit function 4. And our first example, we're looking to see whether 125 is a perfect cube. So I'm going to go ahead and punch in 125. So it's looking to see, can I take the cube root of 125? That's what that is asking. And so then I press enter, and sure enough, I get 5. What does that mean? That means if I take 5 and raise it to the third power, which is the same thing as multiplying 5 times itself 3 times, it's going to get me back to 125. So 5 is my perfect cube root. All right, so let's just get out of here for a minute and go back to what we were doing. So now that we know how to use our calculator to help us, we're going to first find our A. So A is going to be the cube root of each of the factors. So the cube root of 125x cubed is going to be 5x. How did I get that x? I know how I got the 5. Okay, I just took the cube root of 125. The way I got x to the first is if I just take that exponent and divide it by 3. That's all I did. That gives me 1, x to the first. Now let's do B. So the cube root of 1, okay? So if I take the cube root of 1, that's asking me what number can I raise to the third power that's going to equal 1? Well, that's just 1. 1 raised to the third power is going to be 1. So that means the cube root of 1 is 1. That's not so bad. All right, so now let's go ahead and we're going to apply our formula. So to find the factored form, what we're going to do is we're going to take A minus B, then we take A squared plus AB plus B squared. Okay? So now let's just plug in our numbers. So that would be 5x minus 1, because we figured out our A and our B. It's just asking you to plug in the cube roots. Now I'm just going to write it the long way, 5x squared plus each of those terms, 5x times 1 plus 1 squared. Okay, let's go back and simplify. So I've got 5x minus 1 times. You have to square that 5. So it'll be 25x squared plus 5x plus 1. That is the factored form of 125x cubed minus 1. I'm done. It's not so bad. It's really, really helpful to identify your A and your B. So let's do the next one. So remember, the A and the B are simply the cube roots of each of the terms in that binomial. So my A is going to be the cube root of 8, which is 2. 2 times 2 times 2, or 2 cubed gives me 8. Okay? Then the cube root of x cubed is x. Now let's do 27y cubed. That's going to be 3y, because 3 cubed is 27. Again, your calculator could help you out. So now, because this one is the sum of two cubes, our factored form is just slightly different. It's going to be a plus b, and then a squared minus ab plus b squared. So it's just our signs that are different, and you do that remembering that acronym SOAP. Same, opposite, always positive. So now let's just plug in our numbers. So that's 2x minus 3y. This time I'm just going to square everything in my head. So 2x squared is 4x squared. Or I should say 2x raised to the second power is 4x squared. Minus, I'm going to multiply our a's and our b's together. So that's going to give me 6xy plus that 3y raised to the second power gives me 9y squared. Done, 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 done. Okay. Next one. It has a fraction in it, but that fraction is a perfect cube. 8 is a perfect cube. Okay, so again, we're going to figure out our a. All right, so our a is going to be 1/2 x. Our b is going to be 4. So now we've got the sum of two cubes. So let's just go ahead. It's going to be 1/2 x plus 4 times 1/2 x raised to the second power gives us 1/4 x squared. Now I'm going, oops, that should be a minus. I'm going to multiply my two terms together. And so 1/2 of 4 is going to be 2x. So that's where the 2x comes from, just from multiplying those. And actually I should, well, yeah, you might not remember. Where did that come from? 1/2 x times 4 is 2x. All right, plus that b term of 4 squared is 16. That's all done. And I did it in my head. You can too. All right, let's look at number 10. Well, crazy. Look at that. Those exponents are not 3's, but they're multiples of 3. So that means I can find the cube root of those. No problem. Okay, so my a is going to be x cubed. Really? For sure. Look at that. 9 divided by 3 is 3. So the cube root of x is going to be x cubed. Now for my b, the cube root of 8 is 2. The cube root of y to the 15th, well, let's just divide that 15 divided by 3. So I get y to the 5th. Okay. Now, this is subtraction. So this is going to be x cubed minus 2y to the 5th. Now, I'm going to write this out the long way so you can see where all of my exponents and numbers are coming from. So I'm going to take my first term, x cubed, and square it. My sign is the opposite of the original. Then I'm going to take my a times my b. So my x cubed times 2y to the 5th. Notice it's not a negative 2y to the 5th. It's a positive, 2y to the 5th. And then always positive, and I take that 2y to the 5th and square it. Okay, let's just simplify this line. So, x cubed minus 2y to the 5th. Now I use the power rule to multiply. 3 times 2. So that gives me x to the 6. Plus, well, with this middle term here, I really can't do a whole lot. I'm just going to bring the 2 out front, and then I write my variables alphabetically. That's really all I can do. Now for this last one, I take the 2 and square it to get 4. And the y to the 5th, I multiply 5 times 2 to get y to the 10th. There we go. That one is done. Okay, now let's try this one. X cubed minus 216 z to the 6. Okay, so I'm going to go ahead and identify my a, which is x. What's going on? And then if you don't know the cube root of 216, which I kind of don't expect you to, just put it in your calculator. Use that math function and go and find the cube root of 16. It's going to tell you it's 6. All right. So that's going to be 6. And then we take that exponent, divide by 3, because we're looking for cube roots. And so that's going to be z to the 2nd. That's the root. So now let's go ahead, put this in factored form. So I'm going to take both my a and my b. A minus 6z squared. If you're asking, how did she know it was minus? Because the original binomial was subtraction. And so that determines what my first binomial in factored form, what the sign is going to be. Now I'm going to take my first term, x, square it. Well, x squared is x squared. Opposite sign, so a plus. Multiply my a and my b together. So I'm just going to put it in order of my number first, then my x, then my z squared. It's okay to change the order because it's all multiplication. My last sign is always positive, and then I take 6z squared and raise it to the 2nd power. So that's going to give me 36z to the 4th. Done. And I did it mostly in my head. You can too. All right. So try these last 4 if you want a little bit of extra practice before you start your homework. I'm just going to go ahead and I'll do them for you. You can hit pause. I will do them. If you feel like you're ready for your homework, just stop here. Go dive into your homework. If you find the homework's not going so well, come back and try these 4 problems. All right. So for this first one, our a is x, our b is 5. And so we get x plus 5, x squared minus 5x plus 25. For this next one, b, our a is x, our b is 4. This one is subtraction. So this is going to give us x minus 4, x squared plus 4x plus 16. All right, now this next one. Our a is 2x. Our b is 3. So the factored form is going to be 2x minus 3, 4x squared plus 6x plus 9. Now this last one. Our a is x, our b is 1. It's addition. So it's going to be x plus 1, x squared minus x, because 1 times x is x, plus 1 squared is 1. It's done. You did great. You should have everything you need now to do your homework.